well rested, fired up, ready to go after your Christmas break? Dive right into round 2 of physics. Welcome to the second semester of physics. You can see the title on the screen. Today's lesson, Circular Motion Basics. Let's get right to it. Although this begins a new unit for us, it's really a continuation of Newton's laws that we finished right before Christmas. So we're going to pick up where we left off. Okay, circular motion is really a continuation of that, and so we're going to use Newton's first law as our jumping off point for understanding circular motion. Remember that Newton's first law says that objects in motion stay in motion in a straight line at a constant speed unless an unbalanced or net force acts on it. Okay, in other words, if you see an object moving in a straight line and moving at constant speed, you can conclude that the forces on that object are balanced. Okay, conversely, if you see an object not moving at a constant speed or not moving in a straight line, you can conclude that there is an unbalanced force acting on it. So if you look at the drawing on the screen here, okay, it's the drawing of a car moving in a circle. Now, notice that the speed of the car is constant, okay, 20 miles per hour. That means the speedometer says 20, 20, 20, 20. So it is moving at a constant speed. However, you'll see that it's moving in a circle, which is not a straight line, and therefore, even though the speed is constant, okay, even though the speed is constant, we can conclude that there's an unbalanced force acting on it. In other words, objects don't naturally move in circles. They naturally move in a straight line. So because this object's moving in a circle, we can deduce that there's an unbalanced force acting on it, and remember that by Newton's second law, okay, if you remember Newton's second law, I'll write the shorthand version for you here, right? F equals ma, okay? And this part here represents the net force, right? The sum of all the forces, or the unbalanced force. If we have an unbalanced force, then we have acceleration. All right, so this car is actually accelerating. I'll say that again. This car is actually accelerating. Not because it's speeding up, not because it's slowing down, but because it's changing direction. If you remember from first semester, 3 ways to accelerate: slow down, speed up, change direction. So this car is accelerating. Even though the speedometer is reading a constant 20 miles per hour, this car is accelerating because it's changing direction. And that doesn't happen naturally, right? An unbalanced force has to act on it. The next question to consider is, if there's an unbalanced force acting on this car, what is it and in what direction is it? So what I'm going to do is I'm going to draw a free body diagram for the car at this location right here. Okay, it's going to be easiest to visualize there. So I'm going to pause the video, draw the free body diagram, and come back. Okay, let's label these forces together. Okay, pushing the car up is the normal force on the car by the ground. Pulling the car down is the force of weight on the car by the whole earth. And then pushing the car inward is the force of friction on the car by the ground. Okay, it is the friction force that pushes the car to the center, allowing it to move in a circle. And you know this is true if you just substitute the ground for ice, right? If we replace the ground with ice, the car doesn't move in a circle very well. It's just because it's going to slide in a straight line because that friction force is not there. A key thing to recognize here is that the force required to move an object in a circle is a force that points toward the center of the circle, okay, and that force has a special name, okay. The fancy physics name for the center-seeking force is the centripetal force, okay, the centripetal force. And as you have learned already, different forces at different times can make an object move in a circle. In this case, right, of the car moving in a circle, the friction force is the centripetal force. Notice that I don't label on the free body diagram, I don't label any force called F centripetal. Okay, it's not a new type of force. It's the same forces acting to move an object in a circle. So if friction is moving an object in a circle, we call friction the centripetal force. If tension is moving an object in a circle, right, if I take something and whip it around my head attached to a string, that's going to be tension acting as a centripetal force. But never, okay, let me X this out again, never does centripetal show up on a free body diagram. It's just going to be the forces you already know, acting as centrifugal forces. Finally, let's confront the great
enemy of understanding circular motion properly, and that's the word centrifugal or centrifugal. Okay, students love this word. They can't remember centripetal for the life of them, but they love centrifugal force, and they love to talk about centrifugal force. Well, let me tell you something here. The F in centrifugal stands for fake. Okay, the centrifugal force is a fake force. Okay, centrifugal force is outward pointing. Okay, it's the fake force that you think you feel on you when you move in a circle and you feel pushed to the outside of the circle. It feels like you're being pushed to the outside, but actually you're being pulled to the inside. I want you to consider the car in this position here. We're going to draw this straight line, okay? We're going to say that that's the person. Now I want you to notice the following about this person. Okay, and I'll draw the line here. Now, notice that you can push this person to the outside, okay, or, let me draw it here, you can pull this person to the inside. In each case, right, in each case, the person's going to end up like that. Whether you push them to the outside or pull them to the inside. Okay? So what you feel when you're driving in a car is you feel this right here. You feel like you're being pushed to the outside. But in reality, you are being pulled to the inside. Okay? The effect is the same. You just thought that you were being pushed to the outside, and really you're being pulled to the inside. Okay? So the word centrifugal relates to that feeling of being pushed to the outside when actually you're being pulled to the inside. All right? You will never ever see centrifugal force on any list of real forces.